Okay, so combining functions is what we're talking about today. And we're going to start with stuff that's kind of easy. You got these two functions, you got f and g. If you want to add up f and g, this is just the real formal way of kind of writing that. You can see that if you see it like this, you want to immediately change that to something that's easier for us to do, which is just f of x plus g of x. So to add the functions, you would just say this is equal to 1 over x minus 1 plus square root of x. And I've added them. I guess the only thing that's a little bit tricky is the domain. So the domain of this guy would be all reals, except x cannot equal 1. Domain of this guy, you take whatever's underneath there, you take it out from underneath there, and you set it greater than or equal to 0. So x is greater than or equal to 0, and that's the domain of this function. It's already solved for x. So if I want to find the intersection of the two domains, so what's the intersection of x bigger than or equal to 0 and all reals, but x can't be 1? So it looks like it's the combination of the two. You might say x is greater than or equal to 0, but x cannot equal 1. In interval notation, you would say from 0 to 1. Let's see, not including 1. Union with from 1 to infinity. So that would be interval notation for the domain. So the domain is the only thing that's kind of difficult about this. As far as combining the functions, you can see this is pretty pedestrian. We're just adding up f of minus, again, when you see it like this, write it like this. You'd say 1 over x minus 1, which is f of x, minus g of x, which is square root of x. Domain's the same thing that we had right there. So that would be the domain here. Oops, missed a little part of that. So this would be from 0 to 1. And again, for multiplication here, those are the two functions in case you forgot them. Those are just, multiplication is exactly what you might think it is. It would be 1 over x minus 1 multiplied by square root of x. Then the domain, again, is just this repeated again. So you just write that again, because it's just A intersect B. And this last one, we have a little bit of a difference here, so it's a little bit more difficult. So this part is not too bad. We, again, just take 1 over x minus 1 divided by square root of x. You could simplify that a little bit if you wanted to. That's like dividing by a fraction. We multiply by its reciprocal. In that case, you get 1 over x minus 1 times 1 over square root of x, or square root of x down here. So if you want to simplify it a little bit, that's fine. Domain's a little bit trickier here. We've got, normally we would have said something like, 0 to infinity, but not including 1. But there's an extra thing because of this. It's not just A intersect B, but we would say g of x cannot equal 0. Whatever value would make g of x equal to 0 would be not allowed here because g of x is in the denominator. So if you remember, the domain for g of x was x is greater than or equal to 0. Because the g of x can't be 0, we might say the new domain is x greater than 0. And that's going to intersect with the domain of the other function, which was all reals, where x is not equal to 1. So you combine the two of those together, you get something like from 0 to 1 and from 1 to infinity. So almost the same domain that we had up there, almost exactly the same. The difference is really just this. It doesn't include 0 there. So it has kind of a parentheses there. It does not include 0 because again, g of x can't be equal to 0. So you just have to be careful about that. Here's something you'll never see this problem very often in math classes, but I need to show it to you because you have some of this in this section, and we can add functions graphically. So if you consider the this one the f function, and this one the g function. I guess I should write that lowercase. There we go. So if we want to add graphically f of x plus g of x, we can do that. And all you need to do is take, like, let's say we take the value of 3 here. So at 3, you can see, well, let's take it 4. 4 seems easier here. So this is 2 units tall. And this one is, the y value of that function is 3 units tall. You can see how tall, those are the y values of those points. When x is 4, the y values of those points, that's the point 4, 2 and 4, 3. So if you add up those two y values, you get the resulting function would be 4, 5. So that point is when you add up those functions at 4, that's what you get. Let's do that again. So here this, the blue at g function looks like it's about 1.5. 1.5 is what that is. And then the at 3, this looks like to be 3 units tall there. So if I add up both of those together, 1.5 and 3 is 4.5. That looks like about right there. So I'm just adding these graphically. I'm doing this a little faster now. 1 and 2 would be 3. 1/2 plus 1 is 1.5. 0 plus 0 is 0. And then, let's see, this is 2.5 plus 3 would be 5.5. 3 plus 3 is 6. 2 plus 3.5 is 5.5. And 1 plus 1, 2, 3, 4 is 5. And 0 plus that, 0 plus anything would just be that. And there's no function here, so we're just going to stop at this point. So it looks like our function would be something like this. So we try to graph it. We'd go from point to point. It has kind of a weird look to it. That is the graphical, when you add those functions, you get that function graphically, and really adding vertically. And it kind of makes sense. If you think about it, we're taking f of x plus g of x. Well, what is f of x really? That's a y value, isn't it? Plus another y value, because that's another y value. G of x is just a fancy name for y. We're adding up the two y values to get this new y value every time. We're adding up the two y values of the functions. So it kind of makes sense, I think. Okay, so composition of functions is, now you will see this quite often in math class, actually. So we read this. This is the formal notation for composition, function composition. I much prefer to write it like this. So if you see it in this formal writing, please write it as f of g of x. And so it looks almost like fog. It's a little composition symbol there. It's not multiplication. It's composition. We're composing two functions. We're putting a function inside of another function. So we're going to try this and see what happens when we do this. And you just kind of have to work. Order of operations, like you do the inside part first, basically. Okay. So let's try this one. So find f of g of 3. First thing I want to write that as f of g of 3. So that's the better way to write that. And then I want to do the inside part first. So I'm going to do this part first when I do this. So f of g of 3. Do we know what happens when we plug 3 into the g function here? We get 3 plus 1, which is 4. Right? Now, how do I find f of 4? Well, now 4 gets plugged into the f function. So for x, so we get x squared, which is 16. So f of g of 3. Again, we're not dividing by 3 or dividing by g in here. We're plugging in is equal to 16. That is the composition of those functions. Now, if you go in the other order here, g of f of 3, I'm curious if we get the same answer. So we'll go kind of backwards. We're composing f is inside of the g function here. So we always do the inside part of the function first. So we're going to do the f of 3 part first here when we do this. So this is equal to, oops. So this is going to be g of f of 3. So f3 gets plugged into the f functions. That'd be 3 squared, which is 9. Now 9 gets plugged into the g function. 9 plus 1 is 10. So g of f of 3 is a different answer. So function composition is not multiplication. Multiplication is commutative, but function composition is not commutative. So 10 and 16 are different answers. You may notice that. So let's just do a few more here. F composed with g, two different functions, or I don't know if they're the same or not, but we'll just compose the two. So we're going to say of x here. So f of g of x. Since it did give us something to plug in, we're going to plug in x. So we're going to say f of g of x is the inside part of this function, right? So we're going to plug that in here. G of x is x plus 2. And now we're just going to take that and plug it in here everywhere there was an x in the f function. So this will be, instead of x squared, it'll be x plus 2 squared. And when you square that, you will need to multiply this out. So you get x squared. When you FOIL that, x squared plus 4x plus 4. Now let's compose it the other way. So this is really saying g of f of x. And so you plug in the f of x function first. F of x is x squared, so it'd be g of x squared. Now the x squared gets plugged in here for x, and we get x squared plus 2. And so what's weird is you can also plug in g of g here, or g of x, so to speak here. So first we're going to plug in g of x. That would be g of, what is g of x? G of x is x plus 2. Now we're going to plug that back into the g function wherever there's an x. And when you do that, you get x plus 2. We plug that in, plus 2, which is really x plus 4. And now we're going to do f of x. And we get, just plugging in, again, we're going to do the inside part first. So f of x is really x squared there. We're going to plug that back in there everywhere there's an x. So x squared squared, that's kind of weird, x squared squared would be x to the 4th. And lastly, let's look at this function composition algebraically, or graphically, I guess, graphically, sorry about that. So g of 2, again, we can find that graphically. We did this the other day. G of 2 would be right here. That's the point 2, comma, negative 2. So negative 2 is what this guy is equal to, so this would be f of negative 2. Now I'm going to plug negative 2 into the f function, and I get negative 2, comma, 4. So I get this answer of 4. So you're going to get numeric answers here when you plug in this function. Let's try another one, see if we have time here. F of negative 3 would be 1, 2, 3, 4. So that's 4. G of 4 into the g function, g of 4 is negative 1. And so you can continue to do that. You do f of 2, plug that in, and take that answer and plug it into f, and you'll be fine.